Problem number 2. Draw the shear and moment diagram of the beam shown. So the first thing that we are going to do here is to compute for the reactions of the support. Here at point B, we have two reactions here. So we have the dy and the dx. But the horizontal reaction is equal to 0. So let us just denote this as reaction B. And at point D, we have one reaction at the roller. So we have here the reaction at point D. So in order for us to compute for the reaction at point B, what we are going to do is to summate moment at point B. So we have summation of moment at point B is equal to 0, taking the clockwise direction as positive. This 30 kilonewton here will create a counterclockwise rotation. So we have here negative 30 multiplied with the moment arm, which is equal to 1 meter. This 50 kilonewton will create a clockwise rotation, so we have here plus 50 multiplied by the distance of 3 meters. And this RD here will create a counterclockwise rotation, so we have negative RD multiplied by the distance of 5 from point B. This is equal to 0. So computing for the value of RD, then we have negative 30 plus 50 times 3 minus 5x. This is equal to 0. Shift solve equals, and we have here 24 kilonewton. So we have 24 kilonewton since it is positive. So tama yung assumption natin that RD is directed upward. In order for us to compute for the value of RD, we have to summate forces vertical is equal to 0, taking the upward direction as positive. So we have here 30, which is directed downward, so that's negative. The RB is assumed upward, so that's positive. We have here 50 directed downward, so that's negative. And this RD here, which is equal to 24 kilonewton, is directed upward, so we have here positive 24 kilonewton, and this is equal to 0. So computing for the value of RB, then we have negative 30 plus RB, so that's x minus 50 plus 24. This is equal to 0. Shift solve equals, and we have here 56 kilonewton. So this is 56 kilonewton. And since positive yung lumabas na sagot, meaning tama yung assumption natin that it is directed upward. So this time we will be using the area method in order for us to draw the shear and moment diagram. So we have our shear at point A, so that's the 30 kilonewton downward will create a negative shear, so that's negative 30. As you can see here, we don't have any load between A and B, so this 30 here will be just constant up to point B. This is negative 30. And at point B, we have the reaction 56 kilonewton upward. So we have negative 30 plus 56. That is equal to 26 kilonewton. So we have here 26 kilonewton. And we don't have load between B and C. So constant lang itong 26 kilonewton hanggang sa point C. And ibababa tayo ni load 50. So we have here 26 minus 50. That is equal to negative 24 kilo. Wala tayong load between point C and point D. So constant lang yung 24 kilonewton hanggang dito sa point D. And this 24 kilonewton here will be closed by the 24 kilonewton reaction at point D. So aakyat tayo dito, and that would be 0. So this would be our shear diagram. For the moment diagram naman, so our moment at A is equal to 0. So 0 tayo dito. Then our moment at B is just equal to this area here, and we call this as area 1. So this is area 2, and this is area 3. So the moment at B is equal to area 1, which is equal to the area between A and B. So we have here negative 30 kilonewton multiplied by the distance of 1 meter. So we have here the moment at B, which is equal to negative 30 kilonewton meter. So at this point, we have negative 30 kilonewton meter. So since this is degree 0, always plus 1, so we have here degree 1. This is linear equation. So this would be our moment diagram. Now, for the moment at point C, so we have the moment at point C is just equal to the moment at point B plus the area 2. As you can see here, area 2 is positive. So we have negative 30 kilonewton meter plus the area 2. So that's 26 multiplied by the length of 3 meters. So we have here 26 kilonewton multiplied by 3 meters. Waiting for the value of the moment at C. So we have here negative 30 plus 26 times 3. And this is equal to 48 kilonewton meter. So we have 48 kilonewton. Negative moment is negative 30 kilonewton found at the location of the zero shear here. Now, in order for us to compute for the distance of the point of inflection here to point A, and tatawagin natin tong distance x. So, etong distance na to, papunta dito, ay tatawagin ko siyang x sub 1. And of course, we have here 1 meter. So x is equal to 1 plus x sub 1. Now, if we are going to do the ratio and proportion, so we have here x is to 30. So, nineglect lang natin yung sign. And if this is 3 and this is x sub 1, so meaning this distance here is 3 minus x sub 1. So we have 3 minus x sub 1, this distance here. And this is, and the vertical for this triangle here is 48. So solving for the value of x sub 1 here, then we have x over 30 is equal to 3 minus x over 48. Shift solve equals, and we have here 1.154. So the x sub 1 is 1.154 meters. So since the value of x is equal to 1 plus x sub 1, so meaning x is equal to 2.154 meters. So the value of x here is equal to 2.154 meter, which is the same with our x computed here sa ating previous. This is our answer for our problem 2 using the area method.